Okay. All right. Good morning. Welcome to day two of the annual ASBU, ABU, and WorldDAB Technical Workshop webinar series. Thank you for your interest. We hope you'll find today's presentations useful. Today we turn to the technical aspects of DAB+ systems. But first, a little bit of housekeeping. We always like participation on these webinars. So all questions are good questions. There is a Q&A box at the bottom of the Zoom screen. Please enter your questions into that, and we will answer as many as we can in the Q&A session at the end of the day. Any that we don't get to, because if we have too many, will still be answered, and we will publish the answers after the webinar series is completed. So please field your questions. It's always a useful situation. Okay, so first up today, we have Lindsay Cornell. Lindsay is the chair of the WorldDAB Technical Committee and principal systems architect at the BBC in the UK. And he's here to tell us and give us a bit of a technical standards update, recent TC activities, and to remind us how service following should be used in practice. So, and that's especially when establishing new networks. So over to you, Lindsay. Please share your screen and do your presentation. Thank you.
Thank you very much, and good morning or good afternoon, depending on where you are. Yes, indeed. Thanks for the introduction. I'm going to talk about some key technical developments. So let me just get started. So as Les says, I chair the WorldDAB Technical Committee, and this is a group that brings together the technology experts from within the WorldDAB membership. So it really allows us to connect together, collaborate on all sorts of different technical matters. So we discuss new ideas and we deal with problems that people perceive, whether they're real or imagined, and generally talk about the way that DAB is progressing. Our main task really is to maintain and augment the DAB standards. So we keep them stable, but at the same time, we bring them up to date. And I'm going to mention a few aspects of that we've been working on this year. But first of all, just an update on the standards. We've been working on a couple of small modifications really to the standards to extend the flexibility. And there's two topics, public prominence and push to local. So starting with public prominence, this is really a reaction to the way the media environment is developing, a lot to do with IP delivery, and particularly brought about by streaming of TV content. And the concern that some authorities have, particularly in Europe, but also across the world, is that it becomes harder and harder for the public to understand what they call the prominence of any particular program or service. And by that, what they mean is its public value, whether it's news that comes from a known source, a trusted source, and so on. So within the European Union, a decree has been created which instructs the countries in the EU to promote services with public prominence and to make this an issue in terms of their own national media law. And some European countries are starting to implement measures which apply to these connected streaming devices. And although radio has not really been in the forefront of the focus as much as TV has, WorldDAB, we wanted to be ready technically if these measures started to be applied also to digital radio. So we set up a small task force and came up with a little update to the signaling, which allows proper public authorities to declare whether a service has this prominence or not, and this can be indicated to receivers. And it's been done in a way that existing receivers will carry on working perfectly fine. Now, the other topic which touches on the end of this presentation, which is about service following, but this is this modification which we called push to local, and one of the issues with introducing digital services is that the network, the radio network, the coverage network, is not an exact replica of the analog radio network that already exists, whether that be in medium wave or in FM. The frequencies are different, the layout of the transmitters is different, and so on. So there's going to be differences in coverage, which areas are in and which areas are out. And there's also a change to the radio scene because with DAB, it's an ensemble of services, a collection of services together. So you don't just get one service coming on air, you get lots of services coming on at the same time. That's really helpful. But often broadcasters add to their popular analog services with new digital-only services. Because there's more opportunity, they can provide a more diverse range of services to their listeners. And those broadcasters want to keep their analog listeners, but they also want to grow the time that they listen to the new service variants as well. So within DAB, we have mechanisms to connect different DAB services together and also with FM RDS services, and all to enhance the user experience. And this feature is called service following. Now we've developed a new mechanism that allows broadcasters to signal two different levels of preference for alternative sources of the same audio program. And so this is a sort of variation in the service following feature. And primarily it came from an idea from French broadcasters who have moved with digitization from what's essentially local radio, each city with its own radio stations, and quite often spaces in between along the main highway networks that didn't really have any radio services at all, to DAB, which also has a national layer of coverage. So what they wanted was for local listeners to get the local service. So they wanted a way to let receivers know for their automatic retuning, let the receiver know when it could tune to a version with more localized content. So more relevant news, better weather, and more relevant advertising and other content. So again, we thought about this problem. We came up with a solution, and it uses a spare signaling bit that we had left over in the service linking feature. And so we've decided how to use this bit. And when it's a 0, it's the normal preference level, and that's the situation up till now. For all implementations, will signal at a 0. Or we can now indicate a low preference level when we set that bit to 1, and it gives instructions to the receiver to differentiate between these two lists of alternatives, so that they can prefer some services over others when they're trying to decide the best source of the audio. And all the other existing rules within service linking are preserved. So this is an added benefit for the situation originally identified in France, but also now considered to be important in Germany and the UK as well. So a feature which has got more uses. So in terms of the reflecting this into the standards, the rules of implementation, this ETSI standard has been updated to include these new service following rules for push to local. And indeed, the main DAB standard has been updated and republished last month, which is the first change or first revision since 2017. So within this update, we essentially just incorporated the various little tweaks that we've made over that period of time, so that we have a nice clean version of the standard for everybody to work from. And the enhancements that we've included is the use and formatting of text labels in different scripts. So especially that includes the provision for Arabic with right to left script. It includes the emergency warning system and the location coding in terms of the signaling. The other standards are still there for all the rules and implementation details. And we have the signaling for the public prominence and the push to local that I was just talking about. So this brings the DAB standard up to date. So if in future, if you are looking up what is what, this version 221 is the place to go. So let me say a few words now about the current activity within the technical committee. So we're working on a few issues currently. We have a new chairman of the ETI library, file library. This is a resource that allows different ensemble configurations and situations globally to be assessed remotely within a company's own lab. So this is a really useful benefit for members. It cuts down on traveling, allows them to investigate different situations that are on air in different parts of the world. We're also working on extending the guidance for emergency warning system receivers in vehicles. So there's a few issues there. So with a moving vehicle, there's a challenge to decide which alerts are active because the location is changing. And so there are considerations, for example, if the vehicle is going towards the area of the alert or away from it, you might want to do different things in those two situations. And then with satellite navigation, can the location coding and the alerts allow the system to work out that the route might be impacted and alter the routing, whether that be automatically or via a kind of prompt to the user. And we're also thinking about the sort of vehicles that have sleeping quarters, so not just driving, but also vehicles with accommodation, and that's both heavy goods vehicles. The cab often doubles as a bedroom for the driver and for camper vans and so on. So we need different modes for when the vehicle is being driven and when the vehicle is parked up and maybe the occupants are sleeping. And the last task that we're involved in at the moment is developing guidelines for EWS networks. I'll just say a few words more about that. Really, the aim of this work is to develop an interface framework for the emergency warning system origination systems. So we're building understanding between the different companies and the different ways, their experiences with different national authorities, and trying to find agreements on how to build EWS systems where different vendors of equipment can work together. So as these systems get maintained, as they develop, there's more freedom for the network designers to take the best of the equipment from the different vendors according to their situation. So the task force is looking at data formats for exchanging information between service providers and with the authorities and so on. And also they're looking at test cases to help manufacturers align with requirements. They're collecting use cases, looking at different deployments, scenarios and requirements in different territories. So some broadcasters talk about having somebody in the studio with a live audio playout, so making the announcements directly. Others where there's some sort of alerts which are fairly routine in a way, but nobody knows exactly when they're going to happen. Working out the systems for authorized third parties, so that might be the fire authority or something like that, to trigger pre-recorded alert announcements. And also looking at how the signaling for the network, the other ensemble signaling, can be sent via different routes. So using a DAB network or an IP network or a satellite network, whatever the kind of connectivity requirements, looking at how to find the commonalities and therefore produce this sort of interoperability working. So that's really the update on what has happened and what is happening in the WorldDAB Technical Committee. But Les also asked me to just touch back onto the service following topic, particularly for a time of introduction. And I did present quite extensively, quite a lot of detail on service following at this series of workshops last year, and that recording is still available if you want to refer back to it. But service following, as I sort of indicated a little bit earlier in the presentation, but it's a term which is applied to maintaining the same audio, essentially, that the user selected in spite of varying reception conditions when traveling. So this is where, in an analog sense, you would need different frequencies for your FM transmitters so as not to cause interference. If you're covering a large area in DAB, it's probably done with a single frequency network. But when you're driving, it's quite possible that the coverage areas, as I said earlier, of the analog and digital parts might be different. So you might need to switch backwards and forwards. And the way that service following works is it's providing information to the receiver so that it can make the best decision on the source of the audio. So that's signaling from the broadcaster, which identifies different services and behaviors that are programmed into the receiver, which we agree and which are captured in the standards. And the main point about service following is these identifiers have to be properly allocated so that the receiver can follow the rules. So in the analog world, we do frequency planning, and we try to ensure that there's only one radio service available at any given place, so there's not interference between them. And that's done with the frequency planning. With FMRDS, we can add an identifier to that frequency. So that identifier is called the PI code. And this really provides much more information about which service this really is. And it's a machine readable code that the receiver can use. With DAB, the radio services are carried in ensembles. So those ensembles are identified, and also each service in the ensemble is identified. And the way that the identifiers are allocated, it means that every service in a whole country will have a unique identifier. And that's the thing that allows the radio to make its decision, because the basic rule of service following is that entities with the same identifier are exactly equivalent. So if you're tuned to a particular ensemble and you find another ensemble on another frequency, we've got a multi-tuner radio with exactly the same ensemble identifier, the radio knows that's exactly the same ensemble. So although it's on a different frequency, everything inside is the same. So it knows all the services are the same. So that's a really useful piece of information. The radio can decide which version of the ensemble it can receive in better quality and switch to the best one. And similarly, if a receiver finds a service with the same service identifier, it knows that that's exactly the same service. And again, it can switch between those to provide the best quality experience. And this is really the basic rule of service following. And all of that is captured in this ETSI standard TS 103176, and that's including now this update for the push to local feature. But just talking about service following at launch and the sort of more basic elements of service following, as I said, it's very likely that the coverage, especially at launch, will not be the same between analog and digital coverage. It's likely to be larger, smaller, and a different shape, depending on exactly where in the network you are, according to the geography, according to where the new transmitters are placed relative to the old ones. And we know that radio listening is very popular when driving, and that means the receiver will be traveling in and out of different coverage areas. So if we have RDS on the FM transmission, if we allocate the DAB service identifier to be the same as the RDS PI code, that means that car receivers will automatically select between the two, and they automatically select the DAB service whenever it's available, because that's the rules of service following. And this case where there's no extra signaling, it's just the same identifiers, that's referred to as implicit linking. And in terms of launch, if you're going out and starting DAB services, but you don't have RDS on the FM service, it's actually a very low cost addition to add it, because what it does is it helps to speed up the transition to DAB listening, because the DAB receivers in the cars that are coming out will automatically prefer the DAB source for the service, because that's the way they're designed. So here's an example: this blue area, random coverage area for an FM RDS service, and we then introduce DAB to this area, which is this red coverage area, which we can see is not identical. The car receivers, as somebody drives around within this combined coverage areas, the car receivers will automatically switch to DAB when it's available. So whenever it's in the red area, but they'll follow off to FM RDS when the car moves into the blue coverage areas. And as the network develops and the red area increases, gradually it becomes possible to dispense with the FM network altogether and to be purely working in DAB. So finally, just to conclude, the service following, it's a combination of the receiver rules of behavior and some identifier signaling, and it's designed to allow an improved user experience by making sure that the best quality signal is always used by the receiver to provide the audio, regardless of those propagation changes, coverage changes, which happen from moving around. And it's a really important aspect of DAB in vehicles, but to make it work, the allocation by authorities and then the implementation of those identifiers by broadcasters is absolutely essential. So that's me for today. Thank you very much, and I hope you enjoy the rest of the webinar. Back to you, Les.
Thanks, Lindsay. Thanks for keeping us up to date on the new features that are coming out. It's an evolving world, and the TC does a great job in keeping track of that and making sure that the standard is fit for purpose and state of the art, for that matter. So fantastic stuff. We've just been talking a bit about cars and service following. Well, now we're going to have Rosie Smith, who is the WorldDAB Project Manager for Automotive, talk to us about the latest for cars. Future of radio in the connected car, as the presentation says. So looking forward to the latest on what's happening in in-car listening. So over to you, please, Rosie.
Hi, Les. Can you hear me?
Yep, you're good.
Okay, great. Thank you for having me at this event. It's a pleasure to be here with colleagues from all over the world. I can see that there's a lot of you online right now. And in the first slide, if we could go to the next one, I would just like to put a question to this group. When a driver gets into a car, How easy is it for them to choose DAB+ instead of another platform? I want you to hold this question in your mind because we're going to come back to it over the next 20 minutes, because honestly, it's the only question that matters, really. Not does a car have DAB+, but whether the driver actually chooses it. Next slide, please. So WorldDAB did a piece of research this year with 55 Blue, the Car Buyers Research 2026. When asked which audio source drivers listen to the most often in the car, half of car buyers said radio versus 20% of streaming and 12% of personal music. For most of radio's history, we've measured ourselves against other radio stations, AM against FM, one broadcaster against another. That's not the competition anymore. Today, radio sits in the same screen in the car as Spotify, Apple Music, podcasts, YouTube, Audible, and many different platforms around the world. And increasingly, there's an AI assistant quietly deciding what to play before the driver even asks. That's not a broadcasting problem, that's a user experience problem. And it means every one of us in this room needs to think less like a broadcast engineer and more like a product designer, because the driver doesn't care what's behind the dashboard, even though Lindsay gave a fabulous presentation of what is behind the dashboard there. They care about what's easiest. Next slide, please. In the WorldDAB infographic, which you can find on our website, it says the majority of countries in Europe have reached a level where 98% of cars have DAB+ radio. DAB+ is now firmly established across Europe. Australia has proven that DAB+ can work on a national scale across huge differences, and expansion continues steadily across Asia Pacific. In the Middle East, work's already begun on laying the foundations for deployment of DAB+, supported by WorldDAB's ongoing work with ASBU, and one of the reasons we're here today, ABU and ASBU. The thing that every one of these markets has in common is that every single one of these markets took a different route, different regulation, different timelines, different commercial models. So there's no single blueprint for adoption, and that's the same in the car. But this is interesting. There is a common lesson underneath all of these countries, and it's not about the technical developments of DAB+, it's about what happens after the signal reaches the car. Next slide, please. In some research, not by us, but by the AAA Foundation for Traffic Safety in partnership with the University of Utah, they said taking your eyes off the road for just 2 seconds doubles your risk of a crash. It also found that most drivers spend over 40 seconds visually and mentally distracted while completing common infotainment tasks like programming navigation. So that's about a 40 per second pause. So you can see that there is a lot of time there to be distracted in the car. 10 years ago, the question the industry was asked was, does the car support DAB? But today's question has quietly changed to, can drivers actually find DAB+ stations and even radio in the dashboard? That shift sounds small, but it isn't. It's the difference between a checkbox in the OEM spec sheet and a habit that survives in the real world. Think about it from the driver's seat. If you're reaching for your favorite station and it takes 4 taps through a menu, or reaching through a play or going to a playlist and asking one voice command, radio becomes the second choice. People aren't disloyal, they're efficient. They'll always go to whatever's easiest in the moment. So the real threat also to broadcast radio in the car was never really streaming, it's friction. And that's exactly why WorldDAB shifted so much energy in recent years towards user experience, not as a nice to have, but as a strategy to improve the DAB+ experience for drivers in the car. Next slide, please. So in Technology for You, some AIB research said Android Automotive embedded directly into the vehicle, not mirrored from a phone, is forecast to be featured in nearly 90% of mid to high level vehicle models shipped in 2026 this year. So here's the shift in the dashboard. And I think it's something that we all forget how quickly this has happened. So in 2005, the dashboard for audio had one job, and that was radio. A radio button, maybe a few presets, and it was done. By 2015, touchscreens had arrived, and the radio became one tile among several. By 2020, we had fully connected cars permanently online updating. Today, we're driving software-defined vehicles. The dashboard isn't a piece of hardware anymore. It's an operating system that happens to be bolted to a chassis. And tomorrow, but honestly, for some manufacturers today, we're moving towards AI-driven interfaces, where the car decides what to surface to the driver even before being asked. A scary thought for broadcasters everywhere. Here's the uncomfortable truth in the timeline. At every single stage, radio's share of the dashboard got smaller. The number of things competing for the space got bigger. Radio can no longer assume its own space in the car. It has to earn its place every time the engine starts. Next slide, please. So back to the car buyers research. 62% of car buyers rank radio as a must-have feature when purchasing a new vehicle, placing it above built-in navigation and touchscreen displays. A few years ago, WorldDAB recognized that specifications alone weren't going to solve problems in the car. You can have the most technically perfect receiver in the world, and if the interface around it is clumsy, drivers won't use it. So we established the Automotive User Experience Group, now the Automotive User Experience Committee. This committee produced a set of guidelines for both the car industry and broadcasters to help align DAB+ in the car and create the best experience for the driver. The group brings together people who build this experience, so vehicle manufacturers, broadcasters, receiver chipset companies, tier one suppliers, all from different markets with different perspective. Our objective is simple to say, but genuinely hard to do. Make DAB+ broadcast radio feel as intuitive, as attractive, and as connected as every other audio source in the car today, without dictating to car manufacturers how their interfaces should look. We're not writing a rule book that says the radio button must be here. We're identifying the principles that consistently produce a good experience wherever applied, whether that's in a German saloon car, an Italian city car, a Chinese EV, or a vehicle assembled in the Gulf. And I'd say to everybody at this event, this group needs voices from your region. The guidelines are stronger when they're shaped by more markets and more experts, not fewer. Slide 7, please. So again, 91% of DAB+ listeners described the platform as easy to access while driving. That's this year in this year's car buyers research, and we want to keep it like that. So what does good actually look like in practice? It looks like radio that's easy to discover, not buried 3 menus down. It looks like a radio button. It looks simple, with logical browsing, the same way you browse on any other screen. It looks like consistent station logos, so listeners recognize their station instantly, the same ways that they recognize their station on a phone app or on a website. It looks like menus that behave the way the driver expects and controls that don't change from one screen to the next. And critically, it looks like minimal driver distraction. Every one of these principles has to survive contact with the fact that the person using this interface could be doing 100 kilometers an hour. None of it's glamorous, but it's the difference between radio that gets used and radio that gets ignored. Next slide, please. So 95% of DAB Plus listeners say they like using DAB Plus with its richer visuals and better presented experience. Now, here's where the story gets genuinely exciting, because this is where radio stops apologizing for just being audio. Station logos, slideshow, program images, artist information, electronic program guides, traffic updates, visual radio, weather, emergency information, all key for the driver. Every one of these turns a flat audio stream into something rich and, more importantly, current, something that competes with the other offerings in the market. A well-fed metadata pipeline is honestly one of the highest level investments a broadcaster can make in this space. It's something that every market represented in this event today can start working on well before any large-scale rollout. Here's the mind shift I want to leave you with. Metadata doesn't make DAB Plus radio more complicated. It makes DAB Plus radio more useful for the driver. Next slide, please. So 85% of in-car radio listeners say they would miss having radio in the car if it was taken away. This is a strong signal for why keeping the radio experience seamless and uninterrupted through approaches like hybrid radio matter. This is the reality of the car today, because where broadcast and IP stop being rivals and start being teammates, it provides the listener with one seamless service that they never have to think about. This is service following in action, which is what Lindsay spoke about technically, but here it's about what actually happens. The car quietly switches between DAB+, FM and internet, choosing the strongest, most reliable version of the station without the driver even touching a button. Switching between DAB+ live, radio apps and other platforms also needs to be a priority, as radio stations reach listeners on all platforms now with all of their content. This gives you resilience. It gives you enhanced metadata even where broadcast bandwidth is limited. For markets with large distances and mixed connectivity, hybrid isn't a luxury feature. It's a model that fits your geography best, taking your station to wherever your driver goes. Next slide, please. So voice becomes the new interface. SoundHound in Big Village Insights, a survey for US vehicle owners in 2024, said 76% of surveyed drivers now have access to in-vehicle voice assistants, and 86% of those use them every week. Here's a development that changes the whole question I started with. Increasingly, the driver isn't touching a screen at all. The driver's saying, play my station, find me a sports radio station, play the radio, play that station thing, radio, last week news. Voice is becoming the next battleground, and it's a battleground broadcasters cannot afford to sit out of because if the voice assistant doesn't recognize your station name, doesn't know it exists, or worse, redirects that request to a streaming competitor, by default, you've lost the listener before the conversation started, and they may not even realize it's happened. This is the biggest topic right now in the WorldDAB UX committee. It's a work stream that everybody's starting to look into, and something which we have thought about in the past with work on phonemes, but which is now becoming more urgent. Making sure DAB+ radio is properly represented in voice systems is quickly becoming as important as UX design on the screen. So just a little about why drivers continue to use DAB+ in the car. So 31% of car buyers listen to radio every day in the past week. That's more than double the 15% who listen to music on streaming platforms. With everything we've just said about competition, screens and streaming, you'd be forgiven for thinking broadcast radio is fighting a losing battle. It isn't. It's worth pausing to ask why. Drivers keep choosing DAB Plus for reasons that have nothing to do with nostalgia and everything to do with how a car is actually used. It's instant, there's no buffering, no loading screen, and DAB Plus is the thing that starts as your engine starts. It's free at the point of use also. It's reliable in exactly the places streaming struggles, as we've just said. It carries local content, local languages, and local relevance that a global streaming catalogue simply can't replicate. And once a listener finds their station and becomes part of the daily commute, the habit is remarkably sticky. Radio's always been a habit medium. Our job in the automotive UX group isn't to invent a reason for drivers to choose DAB+. It's to remove the friction that stops the habit from forming in the first place. That's really the thread of everything connecting, the thread connecting everything in this talk. The strengths are there. Our work is just to make sure it's still discoverable. So what's next for radio? Global EV sales passed 20 million in 2025. New cars sold with level 2 automated driving capabilities are going to go up to 57.3% in 2031. And Gen Z now spends around 15 to 16% of their daily time with AM and FM in the US. So if that's where we are, let's spend a moment on where we're heading, because I don't think the dashboard's finished changing. There's 3 things converging at the moment. The first is the electric vehicle. EVs are built fundamentally differently. Different electronics, different power budgets, different antenna places. That's a technical conversation broadcasters and car manufacturers need to keep having together, but it's also an opportunity. EV owners tend to be early adopters of everything. They're a receptive audience for a well-designed radio experience if we get it right. We need more discussion on the radio in the next phases of EV development, especially DAB+. The second is self-driving. As more attention is freed up from the act of driving itself, in-car media consumption doesn't shrink, it grows, but it grows differently. That's a real opportunity for richer, more visual and interactive radio experience if radio is positioned to take advantage of it. And the third is young listeners. An entire generation is growing up with on-demand, self-curated, or soon-to-be AI-curated audio as the default experience, not the alternative. They haven't necessarily built the habit of appointment or linear listening the way older generations did. That's not a reason for pessimism. It's a design brief. If we want young drivers to develop a radio habit at all, that habit has to be built into the interface and feel as native and effortless as the apps they use already. I genuinely put to this room as an open question, what does DAB Plus look like for a 20-year-old getting into their first car? Next slide, please. And so in conclusion, again, finishing on some work the WorldDAB infographic shows is that markets are still growing. France and Italy are the fastest growing DAB Plus markets, with the French population coverage now reaching 80%. So here's 5 recommendations for radio in the car. First, coverage gets you into the car, but experience keeps you there. Second, design radio visuals for the car around the driver. Every design decision should be tested against real driving conditions. 3, work directly with automotive manufacturers early, not after the fact. 4, prioritize metadata now. It's the cheapest, fastest way to raise the ceiling on what DAB Plus can offer. And 5, keep DAB Plus, broadcast radio and radio visuals in the future dashboard, including voice and software-defined platforms. Visibility has to be defended actively. It's no longer there by default. Join the international radio community in WorldDAB calling for radio to remain prominent in the car. And then just the final slide. So to finish, half of all car buyers say radio is the audio they listen to the most often in the car. So let's return to where we started. If the driver gets into a new car tomorrow, how easy is it for them to choose DAB+? Every topic covered today, logos, hybrid, service following, voice, metadata, dashboard design, is really just a different answer to that one question. The future of radio in the car will not be decided by one part of the radio experience. It will be decided by the complete experiences that drivers have with DAB+ every time they start the car. Thank you so much for letting me speak to you today. You can find all the information about the car buyers research on the WorldDAB website. You can join the WorldDAB UX committee by contacting us in the project office. And you can find all the information on the infographic also on the WorldDAB website. Thank you very much.
Thank you so much, Rosie. Very great. That's a great presentation. And, I'm just going to have to highlight, the importance of metadata. It makes the user experience so much better, and that attracts listeners and keeps listeners, and that's good for broadcasters too. So that's why broadcasters need to move that just a little bit extra to get their metadata out, just not their audio. Very, very important, and especially important in the countries where listening in the car is dominant. Not in the home, in the car. That happens in a lot of Asian and African countries, Middle Eastern countries as well, I'm sure. Not only in Europe. So very important to keep on top of that. Fantastic. So, okay, let's move on now. We're going to move on to multiplexing systems, and we have Lars Petter Lundgren from Panida, CEO of Panida Sweden, and he's going to talk about a very important topic of security. We've seen a lot of issues come up in the last few years of hacking and, basically taking sites offline. In fact, we had a big one just the other day in Australia. So how do we protect our broadcast infrastructure from hackers and other IP issues? So LP is going to share some of his extensive experience on this topic with us today, which I hope you find useful. Before we go to LP, though, I have to remind you, we have a Q&A box there. Please ask some questions, get in the mix. I'm sure people have thoughts and ideas and have some curiosities. So please write them up into that Q&A box at the bottom of the screen. But for now, let's go to LP. Over to you, please share your screen. Thanks, LP.
Thank you, Les. Hope everyone can see my screen. My name is Lars Petter Lundgren, as Les was saying, and from the company Panida. And we do broadcast networks, mainly in Norway. We have built a TV network. We have a little bit less actually now than 100 transmitters. We also have a business area called safety systems, where we provide typically radio break-in systems for road tunnels. But that business area also includes a warning system like the new standard ASI and other things in using DAB technology. And of course, we provide DAB head-end solutions, multiplexers and audio encoders, and so on. So the topic of today is cybersecurity. Just touching it briefly, it's a complex question, but I'm just going to briefly give you some recommendations. So related to a DAB multiplexing platform, why do we even need internet connectivity? Well, you might not, but it's quite common that we are using audio from streaming services externally related to where the multiplexer sits. So it's quite common that we need audio somehow over internet. It's also quite common that we insert metadata from external systems over internet. It can be content management system, it can be that the playout system is in a different location, etc. So metadata insertion. And the last one, for support reasons and maintenance, etc., we also want to reach the DAB platform remotely. Of course, you can just connect it to internet using public IP, but that's a big no, 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 no. You can't and should never connect your platform directly to internet. It will expose you for a lot of threats. The first thing when we talk about cybersecurity and IT security is that you need a DAB platform that is designed with IT security from the very first beginning. We talk about things like encryption, TLS, HTTPS encryption for every connection, not only for the web interface, but also how you interact with the system, including metadata, other program information, etc. For every connection, you need that to be encrypted. You also need a system that guarantees you that only the port needed for operating the systems are open. All other IP ports shall be closed by design. Another topic is how you register new users in the system. It's quite common that everyone is using the same admin username password. That's a risk, of course. So you need a system where each user of the platform can register themselves by email, etc., and choose their own password. And of course, passwords should never be stored without encryption in any database. It's also a good idea that you specify very unique user rights. Not everyone needs to be administrator of the platform. So if you have a user that is in charge of only metadata, give a metadata access only. And that's also how you build security. Think about how you add users into the system. And of course, it's recommended to use a platform that supports two-factor authentication. So when you log in, you get temporary code that adds another layer of security. And also installing valid certificates give you a trust that the system you're connected to is up to date. Of course, it's always good to have an audit log so you can see who connected, when did he connect, what did they do, etc. That gives you some kind of an early intrusion detection. All right, how do we set up a connectivity using internet but still secured? Well, one thing is to have a firewall, of course, in between, and using external connections connected to that firewall instead, and that firewall using a public IP, of course. So the basic principle is that all external connections connect to that external firewall IP address, and the firewall will forward you to the internal network. This is called port forwarding. On top of the port forwarding feature, you can also add security features like whitelist and source control. IP whitelist means that in the firewall, when you set up the firewall port forwarding, you can also specify which IP address, source IP address, do we allow through this firewall. That adds another layer of security. A VPN solution is also quite secured. So most firewalls today has a built-in VPN solution. Use that. So from the external side, you have a VPN client that connects to the firewall, and they create a secured tunnel, encrypted and secured, and you have full control of who is connecting, and you can have a blacklist and whitelist, etc. That gives you a much better overview. And And another benefit is that it will give you access to the whole inside network, instead of, if you compare to the open port feature, where you need a port forward for everything you need to connect to. So this gives you a better overview, less administration, more secured and more flexible solution. So that's a recommendation. There are also solutions often called and referred to as jump hosts. It's a software solution that sits in the middle between your internal network and the external network. It's a software solution where the basic principle is that everyone connects to the jump host, and that's where you have the administration system, where you can add users, you can define what they have access to on the inside. So this is a quite common solution for bigger developments. It's very secure. The administration is done through a web interface, and it's a centralized administration for the jump host setup. Quite nice. We have some regulations that we need to consider. I'm just to mention two of these now. It's the ISO standard 27001, which is the IT security certification from the ISO organization. And we also have the European Union Cyber Resilient Act. They have a lot of things in common, but they are talking about security by design is a must. It means that cybersecurity must be integrated in software products from the very first beginning. It can't be something that the end user must activate or adding or installing. And it's up to companies like Panida, manufacturers, to make sure that we have minimized the threats in the design and the development, and that security is a built-in feature when you start to use it. So that's the most important thing from the ISO perspective. And the European Resilient Act also add more responsibility for the software manufacturers. For example, we need to present the software bill of material. We need to identify all the components we have used when we develop the software. It's quite common that you use different components that someone else has developed. It can be an open source code module or whatever. All these components that has been used to build the complete software must has been identified. And we need to present an analysis of the risk and threats and vulnerabilities for all these modules. And we also need to demonstrate a routine how we handle security reports and bulletins, etc. And of course, we need to have an IT policy, and we need to demonstrate how we can implement security updates into a system that are in production. So it's a lot of things to consider. So coming back, you need to think about who needs access to the platform remotely or internet, and why do they need it. You can, for example, restrict the access, so only external allowed systems can access, not individual users all the time. And port forward, it's easy to set up, but it tends to be messy with a large number of port forwards for different things. One for metadata, one for audio, one for remote access, etc. So that tends to be messy. So VPN is really preferred and something you should look at. And also think about intrusion detection. How do we detect that someone is trying to hack us? That's something you need to consider and think about. And it was a short presentation, and that's all from me. And over to you, Les.
Thank you very much, LP. I think that's great to highlight just how important it is to have that sort of IP security. At the end of the day, we go to great lengths to achieve high availability of transmissions, 99.99, 5 nines even, which is only a few minutes or even an hour, maybe a year downtime. And it just takes one hack and it can take you out for hours or days. So that's why there's these standards being developed and improved all the time, because hackers don't stand still. So very important to not only do your physical redundancy, but also make sure you have your IT security in place. So you have that resilience. So that brings us on to the next presentation from Alexander Kurz, who's the sales manager at Gates Hair. And he's going to talk to us about the latest transmission technologies. So I think over to you, Alex. Please share your screen.
Good morning, everybody, and good afternoon to our Asian customers. My presentation today will be about the new developments in increased efficiency. So let me go and start the presentation and share the correct screen. So here we are. Les, can you confirm you see my screen?
Yes, that's all good.
Okay, wonderful.
Yeah, sounding good.
So before I start into the increased efficiency, I'd like to reiterate what Lars Peter said about security. Historically, transmitters were standalone devices that had an input, audio source, video source, and were delivering that. Today, transmitters typically are computers that receive their signal from satellite or glass fiber or microwave, convert it and send it out. They are monitored remotely, which means they typically have some sort of connection to a network. Now, if that network happens to be the public internet, I repeat, LP, it's a no, 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 don't do that. So that's the part about cybersecurity I'd like to reiterate. Now, looking at increased efficiency, we have spoken about switching from FM to DAB. Many of you have done that. Several of you are in the process of doing that. I'd like to repeat briefly the efficiency savings that were actually mentioned already yesterday, that going from FM to DAB has a significant impact. Then I'd look at more detailed topics in the latest development, the last 12 to 18 months. And that's my presentation. So when going from FM to DAB, you have significant technical advantages. You're moving the spectrum, you're using wider bandwidth per channel, but you have multiple signals in one multiplex. The operational benefits, much less power consumption versus FM. You share the infrastructure, so the various content providers can share the costs, or as a service provider, you have multiple clients on one station. So essentially, it comes down to the fact that you have up to 18 channels in one DAB multiplex. So that means less frequencies, less transmitters, less license fees, significantly reduced power consumption, and the antenna systems are more compact than if you having 18 transmitters. The power consumption calculation is blatantly obvious how much you're saving. The equivalent of a 10 kilowatt FM is about a 2.5 kilowatt DAB transmitter for the same coverage. The efficiency used to be around 70s. Today, we're talking about 76% in FM. In DAB, we were talking 10 to 15% 10 years ago, then 35 to 40% up to a year ago, and now we talk 50 plus. That means the cost per service has gone from well over $17,000 to about $350. That's $1 a day. So the cost argument for DAB is that it's expensive is going away from the energy consumption. Yes, of course, you need new transmitters, you need new antennas, maybe you need new towers. So there is an investment besides the energy cost, but energy is not an argument anymore. This is a repeat why it's much less requirement for the power level. But now looking at the details of the improving efficiency. Number one, what used to be external equipment is today part of the transmitter itself. So historically, when you wanted to run two transmitters in a main alt combination, you had to have what's called a switchover controller. And of course, you have to have the RF switchover itself. That switchover unit costs money, uses power, and rack space. Today, you can have those controllers built into the transmitters themselves. That's an extra board. They talk to each other and they switch between the two. So that's what we're showing here on the right-hand side. Other components that historically and still today remain external devices are the GPS receiver and the satellite or RF receiver for satellite or RF contribution. Those devices historically have been a dedicated rack space, dedicated power supplies. Yes, the external GPS receiver still has some advantages. We offer those products as well, especially when you have multiple devices in the same station needing a GPS clock. It's more cost efficient to have a single device that delivers the GPS signal to let's say 5 transmitters instead of having 5 transmitters with each with their own GPS clock. But for smaller stations, individual stations, the internal GPS receiver definitely is an advantage. And also today, the EDI input is a standard. So you're delivering the signal via IP networks. And here we come back to the cybersecurity issue. That should be a secure network. The way how to improve the efficiency. This is a slide that I copied from a presentation about a year ago. And why I did that is this was the prototype metrics. We were at that time switching from a different transistors to improve the efficiency. So the new transistor type was improving the efficiency. We were predicting about 5 to 10% at that time. And also the change of the modulation error rate and the efficiency, they have an indirect correlation. So you reduce the modulation error rate, the efficiency goes up. How you do that is basically by modifying the power supply output voltage that's used as a drain voltage in the transistors of the power amplifiers. Now, sounds very technical, at that time, we were dealing with a low MER that was a little bit below 30 dB and a typical MER that's in the low 30s. Now, both of these measures were helping us to increase the efficiency. Les asked me to show a customer who was running low MER, and although I do have a couple customers, I don't exactly know at which MER they are running the systems. But if you look at the actual efficiencies of the product we launched at IBC 25, so that's about nearly a year ago, we now have metrics that allow us to compare what used to be the maximum efficiency at a certain power level and what it is today. And for completeness, I have added the MER values. So what you see is that MER consistently is over 30 dB, and you're still in the 50s up to 56% efficiency. So yes, you can reduce the MER a little bit, and you can increase the efficiency a little bit more, but you're already at a level that is very high. Now, what's also happened at the same time is that what used to be, for example, a 750 watt transmitter in 3 rack units, it's basically that box up here in the upper right corner, moved to 900 watts. So you get more power for the same rack space at significantly improved efficiency at very good MER values. Now, what does happen is if you reduce the power to, let's say, minus 1, 2, 3 dB, your MER goes up to well over 40 dB. So you get a very clear signal, although at a lower power level. What's also relevant is the exciter plus 1 PA. That's a sweet spot for everybody who wants to run a simple system. It's basically an exciter plus 1 power amplifier. It does not need any peripherals. So you can take those 2 or 3 boxes, mount them in a rack, and off you go. You have your system ready. As soon as you go to multiple power amplifiers, like it's shown on the right, you have a rack, you have a controller, you need peripheral equipment, you need a combiner load. So going from exciter plus 1 PA to 2 PAs, yes, you get more power, but it's not linearly increasing the cost. The factor is about 2.5 where it goes up. So that 2,300 watt is relevant because very often we receive inquiries in the range of 1.5 to 2.2 kilowatt. So that covers that very nicely and helps saving money, besides the fact that they are very efficient. One caveat, all these values depend on channels. So when I write 48 to 50, the 48 are typically the low frequencies and the high frequencies, and the 50 are typically the middle frequencies. It has to do with the Doherty principle. You get a curve where the efficiency is not so good at the low and the high areas, and it improves in the middle frequencies. So where did we move in terms of power levels? I already mentioned that we moved to 900 watt in a 3 rack unit to 2.3 kilowatt in a 1 PA combination. What's also interesting is 1 rack air cooled moved up to 10 kilowatt. Again, as soon as you go to multiple racks, you need another power supply, you need another rack, you have more cabling. It's not a linear cost increase, it's faster than linear. The maximum values for air cooled and liquid cooled are more by customer demand. This is not necessarily something we cannot build a higher power air cooled or a higher power liquid cooled, but we haven't seen customers requesting higher powers than that. Design considerations, that's something I did speak about last year and before, and it's always the same thing. You got to consider how redundant you want your system, what's the output power you need, and what's the efficiency you want to be looking at. Now, one thing about the MER is in an upcoming software release, you can set the MER and the power, and the system tries to obtain those output power with the requested MER values automatically. Previously, you had to to set the voltages. And yes, air cooling versus liquid cooling. I'd like to point out, especially for my customers in the Arab countries, air cooling is the preferred way. Why? Liquid cooling has typically an upper limit of 45, maximum 50 degrees Celsius of the incoming liquid, and that is difficult in very hot climates. I don't know how much this applies to Asia Pacific, but I can imagine desert climate or tropical climates, you have similar limitations. We do recommend air cooling with a direct connection to the HVAC system, either via tubed bases or a funnel that's placed on top of the transmitters to avoid overheating of the system. And I think that's basically my presentation. Hey, Les, we're 3 minutes early.
Wow, that's good. Very good indeed. Thank you very much, Alex. It's always good to hear the latest on transmission systems, and I'm very impressed that you, or Gates Air in particular, are gradually compressing more systems into smaller boxes. And hopefully the prices are coming down too, right? That always helps people get on board.
My customers always can ask me about it.
Yeah, well, that's it.
The price per watt is probably coming down. Yes.
You have to be a little bit flexible. I know the costs from what we implemented originally in Australia, I suppose 17 years ago now, are just so much lower. Yeah. It's not uncommon because of volume has gone up. Volume's gone up. Technology has improved. Get lower prices, better reliabilities, better efficiencies, especially on the power efficiency. So all good stuff. All right. Well, we have a question. I think I will answer that one myself. It is a question from Ali Wahib. And he asked the question, please, for Baghdad City, if we're planning to start DAB Plus technology, what is the optimum regular procedure to begin? And what is the perfect country sample we can follow? Finally, what challenge and troubles can we face? Okay, well, that's a big question. That's a huge question. And I'm sure it applies to so many other countries that are considering now implementing digital radio and DAB Plus in particular. So I've got a few answers to that, and I'll just read some of those out because we prepared this earlier. So the first thing is, and this is constructed, these answers are constructed by our team, by the way. First of all, there's no single perfect model. Every market is different. Iraq will be different from Saudi, be different from Algeria, be different from Thailand. The real key is stakeholder alignment, and that's across government, regulators, broadcasters, and network operators. But I'll add a little bit to that because I think the critical one here is the broadcasters. You've got to get your broadcasters aligned and believe and understand what DAB Plus will bring to their business, particularly for commercial operators. Public service as well, it's not as big a question for public services because they're funded by government. Commercial broadcasters are funded by advertising in general. Or maybe if they're community services, they're funded by their sponsors. So actually having belief that DAB Plus will benefit your business, benefit your customers, benefit your listeners, that is so important. And we heard a lot of that from Jackie yesterday, and so many great examples that she produced from expanded coverage to expanded services to pop-up stations and so forth. So a lot of ways that broadcasters can actually improve their offerings and make more money, provide better services, and keep radio listening, vibrant. So to carry on with that, so there's a couple of things we need to do. You're starting from pretty well scratch, I'd imagine, in Iraq. So first you need to develop a national roadmap and policy objectives. Know what you want to do. How much of the country do you want to cover? How soon do you want to cover it? Those sorts of things. What extra services do you want to provide? Because many countries we deal with are totally maxed out on spectrum in FM. There's no more space to innovate. So that's one of the beauties of DAB. It allows broadcasters to do that. So next is conduct technical and business planning, covering spectrum, coverage, business cases, and receivers. The technical part, there's lots of help for that. The commercial part can be a little bit complicated. And I'll refer to the ebook, my ebook, hosted on the WorldDAB website. It's got a lot of information about all of those aspects. Have a read. We just did an update earlier this year, version 2. Begin a pilot or a Baghdad rollout, a city rollout. That'd be similar to what's happened in many other countries. I suppose the things we heard about Thailand yesterday, Bangkok was the initial subject of trials for several years, about 4 years before they ventured into regional areas, for example. And learn from other markets like the Saudi market, which did a fantastic job. Absolutely brilliant. They planned it well. They phased their rollouts. They hit the big cities first to get the biggest population. They filled in the gaps and all the highways between those cities, and they gradually expanding their coverage all the time. And most important in there was actually getting the receivers into market. And that takes time. It takes a fair bit of time to actually get that to happen. You've got to work with the domestic receiver manufacturers. There's lots of brands. Most of them are made in China. And the order time and delivery time is 6, 9, 12 months. So you need to know what you're going to do 12 months ahead of time. With automotive, it's even worse. What you really need to do is tell the automotive industry years before. And if you can get legislation like the EU has done that it requires radio receivers to receive DAB in passenger cars, even better. And we've seen that effect of that in particular in Saudi Arabia again, which started up with a ready-made audience, something broadcasters like. When we established in Australia, we had no receivers. We had to build the receiver base from ground up, from zero, both domestic and cars. So here's a real opportunity to drive that. Now, a lot of these strategies are actually in the public policy toolbox that Dr. David talked about yesterday. So I really advise have a look at that, give that a good read, because it really provides very, very good guidance. So so the next thing is develop a whole marketing campaign for the launch of services well ahead of time to educate the listening audience about DAB+, particularly about new digital-only services. Having that marketing is essential. It needs to be not only on radio, but on TV, on bus backs, bus sides, taxi backs, all of that stuff. Only then will you start to get the attention of the audience. And there's things you can do too. You can do things like giveaways, giveaway receivers. I remember for the 3rd anniversary of Australia, when we actually had some real listening, we actually got cars, because cars were only coming out with DAB Plus about 2012. That was the early days. So we had 5 cities, 5 cars. And we had a whole load of competitions for people to actually win those cars. So that created a great stimulus for people to get involved and say, what is that DAB thing? What's it doing? Oh, I can listen to this now. I can listen to that language, and I never could listen to that language before. Those sort of things, or this type of music, or that current affairs. So the real key challenges here are stakeholder consensus, funding, government assistance in that space through things like licensing for broadcasters, giving them some assistance in that way. Or in some countries, it's actually required to provide some assistance to the infrastructure providers as well. Yeah, Indonesia is going to have to be one like that. As in fact, get affordable receivers, get public awareness, attractive content. Now, there's lots of resources, as I said, that regulatory and policy toolbox. That's a real beauty, a new one. We've got the Establishing DAB Plus ebook. And of course, WorldDAB have a whole range of other supports and advices, whether it's automotive, whether it's the marketing committee. How do you put a marketing campaign together? For example, lots of experience, and that experience is readily transferable to those who want to get involved. So my advice would be write to the project office at worlddab.org, and they will get back to you straight away and provide a whole load of information about how you can move forward in the best possible way. So, right, we're actually pretty well on time now. I just check no other questions. Any questions you want to ask, maybe tomorrow? You can always bring questions from yesterday or today to tomorrow. And if we don't get time to answer them, we will still publish the answers anonymously. So you'll know your question, of course. But if you don't want to be known, you can just put anonymous. That's fine. Not a problem. But at this stage, I think we're going to hit the deadline. So I'll now move on to thank our presenters today, Mr. Lindsay Cornell, Rosemary Smith, Lars Peter Lundgren, and Alexander Kurz. Thank you for your excellent presentations. I hope that our audience appreciated those. We had a pretty good audience today, so that's fantastic. Tomorrow, we're moving on to network aspects, network design and delivery, rather than systems. So another technical day, and I hope that you can attend tomorrow and ask some questions. That'd be a good thing. So for now, thank you very much. And thanks again all to our production team as well, who've done a fantastic job today, as usual. So, and thank you, the audience, who are the most important of all. We hope that was very useful and helpful for you. Contact us anytime through the project office. Any questions to any presenters, contact us through the project office at this point. And we'll publish all of this material after the webinar series is complete. So for now, I'll say goodbye and au revoir, as the case may be, because we'll see you tomorrow. And hopefully see you tomorrow. Cheers. Bye-bye for now.
Bye.
Bye.
Bye-bye.
Thank you. Thank you, Dr. Les. Bye.
Thank you. Thank you all.
Thank you, guys.
Thank you, everybody. See you tomorrow. Bye.